Module 6, Part 2, Hypothesis Testing. Now we turn our attention to understanding statistical significance. A low probability value casts doubt on the null hypothesis. How low must the probability value be in order to conclude that the null hypothesis is false? Although there is clearly no right or wrong answer to this question, it is conventional to conclude the null hypothesis is false if the probability value is less than 0.05. More conservative researchers conclude the null hypothesis is false only if the probability value is less than 0.01. When a researcher concludes that the null hypothesis is false, the researcher is said to have rejected the null hypothesis. The probability value below which the null hypothesis is rejected is called the alpha level, or simply alpha. It is also called the significance level. When the null hypothesis is rejected, the effect is said to be statistically significant. For example, in the physician's reactions case study, the probability value is 0.0057. Therefore, the effect of obesity is statistically significant, and the null hypothesis is that obesity makes no difference is rejected. It is very important to keep in mind that statistical significance means only that the null hypothesis of exactly no effect is rejected. It does not mean that the effect is important, which is what significant usually means. When an effect is statistically significant, you can have confidence the effect is not exactly zero. Finding that an effect is statistically significant does not tell you about how large or important the effect is. Do not confuse statistical significance with practical significance. A small effect can be highly significant if the sample size is large enough. On the other hand, you can't tell by looking if you think an effect is large that it will be statistically significant. Why does the word significant in the phrase statistically significant mean something so different from other uses of the word? Interestingly, this is because the meaning of significant in everyday language has changed. In the 19th century, when the procedures for hypothesis testing were developed, something was significant if it signified something. Thus, finding that an effect is statistically significant signifies that the effect is real and not due to chance. Over the years, the meaning of significant changed, leading to the potential misinterpretation. The current definition of significant is something that is sufficiently great or important to be worthy of attention, noteworthy. Statistically significant does not necessarily mean the effect is noteworthy or worthy of attention. Tests for significance. There are two approaches, at least, to conducting significance tests. In one, favored by R. Fisher, a significance test is conducted and the probability value reflects the strength of the evidence against the null hypothesis. If the probability is below 0.01, the data provides strong evidence that the null hypothesis is false. If the probability value is between 0.05 and 0.01, then the null hypothesis is typically rejected, but not with as much confidence as it would be if the probability value were below 0.01. Probability values between 0.05 and 0.1 provide weak evidence against the null hypothesis and by convention are not considered low enough to justify rejecting it. Higher probabilities provide less evidence that the null hypothesis is false. The alternative approach, favored by statisticians Neiman and Pearson, is to specify an alpha level before analyzing the data. Alpha of 0.01 corresponds to confidence level of 99%, which we studied before. An alpha of 0.05 corresponds to a confidence level of 95%, and so on. If the data analysis results in a probability value below the alpha level, then the null hypothesis is rejected. If it is not, then the null hypothesis is not rejected. According to this perspective, if a result is significant, then it does not matter how significant it is. Moreover, if it is not significant, then it doesn't matter how close to being significant it is. Therefore, if the 0.05 level is being used, then probability values of 0.049 and 0.001 are treated identically, and you can see the 0.049 value was almost big enough to be rejected. But the 0.001 value was much smaller than the 0.05. Similarly, probability values of 0.06, which is just barely above the 0.05 level, and 0.34, which is way bigger than the 0.05 level, would be treated identically. The p-value is the probability of observing a sample statistic more extreme than the one observed under the assumption that the null hypothesis is true. A small p-value says that it isn't very likely the result you observed happened by chance and gives evidence to reject the null and support the alternative hypothesis. Modern convention leads more toward reporting the p-value and letting the reader decide whether the evidence is strong enough rather than using either of the two previous approaches. Question. Given that the null hypothesis says the population mean is equal to 18 and the alternative hypothesis says the population mean is less than 18 and the probability value is 0.070, do you reject or fail to reject at the 0.05 level of significance? Stop the video before checking your answer on the next slide. You would fail to reject the null hypothesis because 0.07 is greater than 0.05. That means there is a high enough probability that the effect you observed happened by chance that you don't want to risk attributing the effect to whatever you were testing. In social science research, it is conventional to reject the null hypothesis if the probability is lower than 0.05. Social sciences include such fields as psychology, sociology, economics, history, and education. Question. Select all that apply. The probability value below which the null hypothesis is rejected is also called the... Stop the video and make your choice before checking your answer on the next slide. Two other common names for the probability value below which the null hypothesis is rejected are the alpha level, or just alpha, and the significance level. Question. When comparing test scores of two groups, a difference of 1 point would never be highly statistically significant, even if you had a really large sample. Stop the video and answer the question before checking your answer on the next slide. Do not confuse statistical significance with practical significance. A small effect, like a 1 point difference in this case, can be highly statistically significant if the sample size is large enough. Below are examples of claims regarding a characteristic of a single population. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today, so the parameter being studied is population proportion or percentage. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. So the mean is the population parameter under study in this case. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So in this case, standard deviation is the population parameter under study. Caution: we test these types of statements using sample data because it is usually impossible or impractical to gain access to the entire population. If population data are available, there is no need for inferential statistics. Hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. Steps in hypothesis testing. First, a statement is made regarding the nature of the population. Second, evidence, sample data, is collected in order to test the statement. Third, the data is analyzed to assess the plausibility of the statement. The null hypothesis, which is denoted H sub 0, or sometimes called HO, is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference. The null hypothesis is assumed true until evidence indicates otherwise. In this module, we are considering only hypotheses about the value of a population parameter. The alternative hypothesis, denoted H1 or H sub A, is a statement that we are trying to find evidence to support. In this module, it will be a statement regarding the value of a population parameter. In this course, there are 3 ways to set up the null and alternative hypotheses. The null is always equal, so we could have equal versus not equal, which would be a two-tailed test. So your null hypothesis would be the parameter equals some value, and your alternative hypothesis would be that that parameter does not equal some value. And you'll notice that our normal probability distribution that we've spent so much time on in this class is coming up again. The second possibility is that we have equal versus less than, which would be a left-tailed test. So our null hypothesis would be that our population parameter equals some value, and our alternative hypothesis is that that parameter is less than that value. The third possibility is that we have equal versus greater than, which would be considered a right-tailed test. Here, the null hypothesis is the parameter equals some value, and the alternative hypothesis would be that the parameter is greater than that value. In other words, the null hypothesis is a statement of status quo or no difference and always contains a statement of equality. The null hypothesis is assumed to be true until we have evidence to the contrary. The claim that we are trying to gather evidence for determines the alternative hypothesis. For each of the following claims, determine the null and alternative hypotheses. State whether the test is two-tailed, left-tailed, or right-tailed. Stop the video before looking at the solutions on the next slides. In 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. The hypothesis deals with the population proportion. If the percentage participating in charity work is no different than in 2008, it will be 0.62. So the null hypothesis is HO. The proportion is equal to 0.62. Since the researcher believes that the percentage is different today, the alternative hypothesis is a two-tailed test that the actual proportion is not equal to 0.62. And we could have stated those as percent is equal to 62% and percent is not equal to 62%, rather than using the decimals or proportions. B. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. The hypothesis deals with a population mean mu. If the mean call length on a cell phone is no different than in 2006, then it will be equal to 3.25 minutes. So your null hypothesis is the population mean equals 3.25. Since the researcher believes that the mean call length has increased, then the alternative hypothesis would be that the mean is greater than 3.25, and this would be a right-tailed test. C. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. The hypothesis deals with a population standard deviation, sigma. If the standard deviation with the new equipment has not changed, it will be 0.23 ounces. So your null hypothesis is that the standard deviation is equal to 0.23. Since the quality control manager believes that the standard deviation has decreased, the alternative hypothesis would be that sigma is less than 0.23, and this would be a left-tailed test. Now take the Module 6 Part 2 Assessment of Learning. The password is reject in all lowercase letters.